Now I'd like to talk about the final unit of running, and this is external forces and Newton's laws in running. So basically what goes on outside the body when we run. So Newton's first law is the law of inertia. Basically an object at rest will stay at rest, and an object in motion will stay in motion until acted upon by an unbalanced force. And we see with running, when still in acceleration, it takes a lot of energy. Well, we can talk about it with sprinters. When still in acceleration, it takes a lot of energy to start, because of inertia. We see this with a 50-meter sprint, which is longer than half that of a 100-meter sprint. Even though it's a shorter distance, to go from still to moving takes a lot of energy because of the law of inertia, and until it has to be acted upon by the unbalanced force of the elastic energy in your legs. And the second part of Newton's first law can also be seen with sprinters. When they pass the finish line, they're going really fast. It takes quite a few meters for them to come to a stop, because an object in motion wants to stay in motion until acted upon by the unbalanced force of, first of all, friction, and second of all, sometimes the reverse elastic energy of them trying to stop themselves. Then with Newton's second law, it's pretty simple with running. So the force that drives a runner forward is the propulsive force of force X. And the speed and acceleration of a runner is directly related to the magnitude of this force X. If a lot of force is applied to a runner, he goes faster in this direction. And if less force is applied, then he goes slower. And then, as we talked about before with Unit 2, Newton's second law also talks about the acceleration being inverse to the mass. So that means that the bigger something is, the more the more force will have to be applied for it to accelerate at the same rate. Anyway, this sums up Newton's laws, and now we're going to talk about forces. So when a runner's running, you've got force X propelling them, you have force gravity pushing down, right? So gravity has a pull on anything that has mass. And force normal is the force of the ground pushing up on the runner. Now we have force friction, which is when the feet come in contact with the ground. Then you also have force drag, right? Because air doesn't want to move, and it's described as a liquid friction, right? The friction, kind of like in a liquid. We have drag with planes, and we saw that in Breaking 2 for the marathon. This was a big thing, drafting off other runners. In their project, they would have certain formations to direct wind. Anyway, this sums up my physics of running. See y'all later.